Hi, I'm Jim Gordon. For St. Patrick's Day this year, my daughter challenged me to use the power of Salesforce to catch a leprechaun. So she's 6 years old, and apparently this is a trend now where leprechauns are nocturnal creatures that sneak into your house and play pranks like leaving glitter on things and funny drawings and that kind of thing. But apparently if you catch the leprechaun, you get their gold. So with that in mind, I was given a deadline of St. Patrick's Day and was asked if I could use the power of Salesforce to catch a leprechaun. So for requirements for this project, we needed a way to catch the leprechaun without harming him. So that's where we used some of our physical devices, Internet of Things type setup. We also needed to avoid any false alarms. So we needed to positively identify the leprechaun using computer vision or Einstein vision. And then we needed to send up the alert once we had the leprechaun via text messaging. So before I show you this project, I will provide some disclaimers. This is just a proof of concept, sort of a hackathon kind of thing. This is not production ready code. You are free to use any of this that you see fit for your own educational projects as well. And I really wouldn't have been able to get this project off the ground without some of the other projects that have pointed me in the right direction. So the Enforce library takes care of a tremendous amount of authentication, record writing, and things like that. There's also a project out there where a Tessel was set up with a check-in system in Salesforce. It's very similar types of connections. And so all of these projects also, Reed and wrote an article about connecting Tessel to Salesforce as well. So that kind of helped point me in the right direction. So I'll leave links to all of these in the body of this post so you can check those projects out. But I wholeheartedly thank them for their input. So here is an architecture diagram for our trap. So as you can see, this is the classic box and string trap. The leprechaun, there's a magnetic switch at the base, and the leprechaun is going to activate that magnetic switch. At that time, the Tessel is going to use a webcam to take a photo. That then also simultaneously we're going to trigger the trap and pull the string with our motor. The Tessel computer board is going to then send that photo to Salesforce, write it into the record. Salesforce is going to use Einstein vision prediction to determine the probability that what we just took a photo of is in fact the leprechaun. If we pass a certain threshold and the leprechaun is detected in the image, we're then going to send a SMS text message alert. Here is the physical trap. It's much different looking than the architecture diagram, but that is it. So hardware that you'll need for this project are a Tessel 2 microcontroller. We'll talk more about that in a second. A breadboard for wiring, a magnetic door switch, motor driver, and a webcam for the picture purposes. Almost all these devices can be found in the Johnny 5 Inventor Kit from SparkFun. So if you want a Tessel and a whole bunch of connecting hardware, I would recommend getting that, except for the webcam. The webcam doesn't come in any particular kit. It's just a USB webcam. So Tessel 2 is a really cool little microcontroller. You've probably heard of Arduino. This is not an Arduino. Arduino is a C-based language and doesn't come with built-in connectivity and things like that. A Tessel runs on basically on the web with one line. It just needs your Wi-Fi password and it's set. But the cool thing is it's running JavaScript, so you can use Node.js and all the web service connections and things like that. So it's very friendly for life on the web. So for those of you that don't know about Einstein Vision is Salesforce's vision prediction service. It is very, very powerful, and I highly encourage you to check out the Einstein Vision Quick Start at this link here. Basically, the steps that were involved for this project were connecting to Einstein. I just used from the documentation, I just used curl, but there is an Einstein Playground app that you can add to Salesforce. So I'll let you do this via the UI. But then I created a model of leprechaun recognition, and then I trained that model using positive and negative images. So that could be one of the more time-consuming parts of this type of project. So if you do this, you want to pick something that you can get images, cats or something like that, where you can get a lot of images quickly. So the more exotic your images, the more you're going to do the legwork to find them. So on the Tessel microcontroller, this is the snippet of the JavaScript code that was used. And so basically, the trap detects the movement. These motors then move forward for a half second, and that pulls the stick out. And at the same time, the web camera captures an image and starts writing that and authenticating to Salesforce. We use Enforce to connect to Salesforce and start attaching the image. And then we listen for the Einstein prediction results from the Salesforce backend in Apex. As far as Apex classes go, I use the Einstein Vision Quick Start classes. So that is in Trailhead, and those are pre-packaged classes that handle like OAuth between Salesforce and Einstein, and then also the vision prediction results. You actually get a vision object back, and you can do things with it. So I did create a small My Service class. It's just a public web service that returns the prediction results directly back to the Tessel. I did that so we could light up different lights, or if you have a siren that you plug to it or something like that, you could do that. And then also the custom class handles the text message thresholds as well. I think if it's 70% probability of a leprechaun, we're going to go ahead and send our text message. And then of course we've got Twilio as a great text messaging platform that has helper classes as well. So in the end, the trap runs, and quite successfully. So we did get some false positives, but you can see on the right here, it's the node console that the trap would engage and write the file and get back a prediction from Salesforce. And then on the phone, you can see that the Leprechaun alert SMS message would post. So in the end, the Leprechaun was caught. And because they were caught, the rules are that they have to fork over their gold. So here is the little pot of gold. It's chocolate coins that the leprechaun was forced to leave, along with a little toy. It was just a fun way to dive into the Einstein setup and spend time with our daughters. That was nice. So final considerations on this project. Yeah, it'd be interesting to see if you can increase the speed to be able to return a prediction before springing the trap. Like how fast can you make the prediction come back? I would recommend some type of demo mode for parents so that as you're testing and doing different things, you don't send any text messages that you don't want. Also, you would have to fine-tune the model in the real world. So typically you would give it the model data and then test it and then give it feedback to fine-tune the model. So that's why we got our false positives, some of our false positive leprechaun results. If I ran out of time, but I would have put the photo of the leprechaun into the body of the SMS message, the text message, so it could be seen. That would be a fun little visual. Also, probably should switch this on the back end to using content version in Salesforce instead of attachment. And then, this project really could be repurposed for anything. So animal classification, attendance tracking, even Easter Bunny. Basically, if you can grab an image, you can classify it with Einstein Vision, which is pretty cool. So I'm going to post these slides to LinkedIn, but if you have any questions or comments, I'll include some links, but feel free to message me, and thank you for your time.